mentioned because of the yesterday we are I was unable to conduct the class because of the already the reason was mentioned. So we are going to complete the remaining portion of the one of the friend is given Mr. Satya. Thank you for giving us this time. So sorry my dear friends, the mic was off because some technical issue. I was talking to the the technical person here, so I kept my mic was off. I hope now you are able to hear my voice now. I hope now you are able to hear my voice now. Is it okay now? So I'm going to write down the answers. Chapter number 7. Question number 7. Question number 7 is Delhi. Question number 13 is Bombay. Question number 14, Delhi. Question number 18 is Bombay. Next, question number 28. C. Question number 30 is Bombay. (33) is Bombay. (37) 86 megapascals, 86.67. I hope you have completed all these questions. Somnath Mandal is given the answers: 7 Delhi, 13 Bombay, 14 Delhi, 18 B, 28 C, 30 Bombay, 33 Bombay, and 37 86.66. And 40, I've forgotten, 40. One 15.97 megapascals. Good. Kumar, all my answers are correct. Okay. So this question, some students are going to get it out. Is a question number 40. It is a very standard question. I am going to discuss this question in the class for the last almost 20 years. But the same question was repeated, GATE and ESC in the recent papers now. Now write down a question here now. For a point under biaxial state of stress, the principal stresses are, for a point under biaxial state of stress, principal stresses are 120 megapascals, 120 megapascals respectively. 120 megapascal respectively. Determine the following. Determine the following. Determine the following. Number 1. Normal stress on an oblique plane. Shear stress on an oblique plane. First question. Shear stress on an oblique plane. Shear stress on an oblique plane if normal stress on that oblique plane is 80 megapascals. Normal stress on that oblique plane is 80 megapascals. Number 2. Number 2. Normal stress on an oblique plane. Normal stress on an oblique plane. If shear stress on that oblique plane, shear stress on that oblique plane is 20 megapascals. Shear stress on that oblique plane is 20 megapascals. What is given in the question now? Principal stress are given as 100 and 120 megapascal respectively. Determine shear stress on oblique plane if Normal stress on that oblique plane is 80 megapascals. Normal stress on the oblique plane, if shear stress on that oblique plane is now. So once you know principal stresses, directly can draw the question number 37. Answer is 86.66. 50 root 3 you are going to get it now. Question number 37 answer will be 50 root 3, that is 86.67 megapascals. 50 root 3. Check it, 50 root 3 will be 86.67 megapascals. If any of the friends are not getting, cross check your once again your solution once again. Okay. So here directly the principal stress are given now. Principal stress are both are going to be positive. So circle will come on the right side of the origin. So first draw the Mohr circle. First draw the Mohr circle. Once you know principal stresses, directly can draw the Mohr circle. For this question, Mohr circle is the better now, because theta is not given here now. If the theta value is given, your analytical method also can be used it now. But theta is not given. In that case, for this question, Mohr circle is the better. I have already mentioned Mohr circle is better for some question now. For these two question, Mohr circle is the simple. Analytical method is the time taking now. Analytical method will become simple when theta is known. But in this question, theta is unknown. Once you know principal stresses, directly can draw the Mohr circle. Both the principal stress are positive. These coordinates are 100, 0. This coordinates is B, 20, 0. This only yesterday, this circle will not give the absolute tau max. For this case, we want to get the maximum shear stress at a point. Absolute tau max, 3 more circles are compulsory, because the circle is not intersecting. So what the next one is asked now? First locate the center. What are the center coordinates? No, sigma 1 plus sigma 2 by 2. That is, the center is going to be 60, 0. What is the next step now? It is a major principal plane. Minor principal plane. Next, These are the tau max planes. These coordinates are 60, 40. So this is sigma and star. This circle will give the in plane. It will not give the absolute. This you have done already yesterday question, day before yesterday. Red color lines are the principal plane, blue color lines are the tau max planes. Next, what is given now? X coordinate is given. Now you have to find out the y coordinate. Can you locate this point now? So this coordinates what you have studied now. X coordinate normal stress, y coordinate shear stress. Now what is given in the question? A normal stress given, x coordinate is given. Now y coordinate is unknown. Then how to find out this? Now first create a plane. Plane means you have to create the radial line, join C and E. Create a plane. Every radial line is a plane. Plane. So this is one oblique plane, but theta is unknown. Theta is known only when you know sigma x and tau xy. But in the question, sigma x and tau xy is unknown. So we cannot find out the location, only can. Now you have to find out the tau s. How to find out the tau s now? Drop a perpendicular, construct a triangle. Drop a perpendicular. Now you know this height you have to calculate it now. What the CE radius, what the radius now? 40. And what about the CF now? Already this 60. What the F coordinates now? 80, 0. So this will be 20. Now you can find out the EF. Now you can find out the EF directly from this triangle. What this value now? Tau S. Now directly can find out the tau s by what? The square root of 40 square minus 20 whole square. 40 square minus 20 whole square is going to give the tau s. So you can find out this value directly now. $34.64. $34.64. Why you are getting a plus or minus? Now this is going to be what now? Plus. I have taken a point above. So I have taken the point below. But the E and G coordinate now on a vertical line. X coordinates are same, Y coordinate different. What the E and G? X coordinate is how much now? 80. Y coordinate is minus tau s. So for E and G, X coordinates are equal unlike, but Y coordinates are equal unlike. So what this value now? Now you can see now these planes are not complementary planes. These planes are not complementary. CE plane and CG plane are not complementary. What you have studied now, whenever the shear stress are equal and unlike, whenever the shear stress are equal and unlike, that planes need not be a complementary plane. But always on complementary planes, shear stress are equal and unlike. That clearly written now. Always on two mutual perpendicular planes, shear stress are equal and unlike. But when shear stress are equal and now on CE plane and CG plane, CE plane and CG plane, shear stress are equal, but they are not complementary. But the angle between this is not 180 degrees now. So always, whenever shear stress are equal unlike, they are not complementary planes. But whenever what they are mutual perpendicular planes, shear stress are equal unlike. So always on two mutual perpendicular planes, shear stress are equal unlike. But when shear stress are equal unlike, they need not be a complementary planes. So this is a simple question. Both plus is correct and minus is correct. Both are going to be correct. If it is given a MSQ question, if it is given this question is the MSQ, plus 34.64 is given, minus 34.64. Both are going to be correct now. Both are correct. So whenever what, if I know the shear stress, you can find out the normal stress and vice versa. In this question, normal stress given, you can calculate the shear stress. Second question, what is given now? Reverse is given. Shear stress given. Now you have to find out the normal stress. Now, F. What the F coordinates once again now? F coordinates are sigma and comma tau s. F coordinates are sigma and comma tau s. But which one is given now? Shear stress is given. But here, now I am removing this now. Now G or H. So already if you have completed, then you can take it as some H and I. Now for H and I, which coordinate is same? H and I. H and I. Y coordinate is same. Sigma n dash. But tau s dash equal to tau s. H and I. Now this is what this value now? 20. Now once again create a radial line. First create a plane now. Now once again you can construct a triangle. You can construct a triangle. J. Now once again, what this now? Radius. What the radius now? 40. Now this value is how much now? 20. Y coordinate is 20. Y coordinate is 20. Now you can calculate now. So what this Cj now? Square root of 40 square minus 20 square means once again you are getting this value. How much is now? This value how much you are going to get it now? 34.64. So this also 34.64. Now what the sigma and dash now? 60 plus 34.64. C, that is what now? OJ. OJ equal to how much now? OC plus CJ. I need the sigma n. Sigma n means I need the OJ. OJ equal to OC plus CJ. Sigma n is equal to OK. OK equal to OC minus CK. What the OC? 60. From HCK triangle. Next. Sigma n dash equal to OJ. OC plus CJ. OC, what the OC value now? 60. Anurag, they're all good, correct. So this question is similar to question number 40. But in the question number 40 is asked, only the first question is asked now. So what the advantage of this Mohr circle now? What the advantage of the Mohr circle? If I know principal stresses, if I know the principal stresses and normal stress on one plane, directly can find out the shear stress on that plane and vice versa. First question, normal stress given, you have to ask to find out the shear stress. Second question, shear stress given and ask to find out the normal stress. So this question may be likely to be asked as a MSQ questions are possible. Two options are possible and two answers are possible for this question. One will be a 25.36. This value is 25.36 and this will be 94.64. Similarly, first question also going to be MSQ question, but both are going to be equal unlike. One will be a 34.64, another one will be minus 34.64. Okay, no problem. Now, in place of the Mohr circle, what the other way can also do is a simple one. There is no mathematical, directly can give the answers now. There is no need to remember any equations now. But if you want to still save the time, without doing these calculations, still you can do this question if you know the circle equation. What the circle equation? There is a more circle equation required. But the circle equation, everybody is going to tell x square plus y square plus r square. That equation is valid when center and the origin is coincide. But always more circle and center may not coincide. So what the generalized equation of a more circle? What the generalized equation for a circle equation? X minus xc whole square plus y minus yc whole square is equal to r square. X minus xc whole square plus y minus yc whole square is equal to r square. X minus xc whole square plus y minus yc whole square equal to r square. Here x means sigma n, xc means what the center coordinates? No, sigma 1 plus sigma 2 by 2. Y means tau s, yc 0, which is equal to r square. What the r square? No, r is equal to sigma 1 minus sigma 2 by 2. So what the circle equation you can write down now? Sigma n minus sigma 1 plus sigma 2 by 2 whole square plus tau s whole square, which is equal to sigma 1 minus sigma 2 by 2 whole square. The second way can, without drawing the circle, this question also can be done by using more circle equation. By using more circle equation, that is here x means sigma n, xc means r square sigma n minus sigma 1 plus sigma 2 by whole square. So you know sigma 1 directly principles are given. First question what is given now? Sigma n is given. Then you can find out the tau s. So what the advantage of the equation now? If I know the principal stresses and if I know the normal stress on one plane, directly can find out the shear stress on that plane and vice versa. So somebody who knows this equation, he can also directly can do it now. Either you can draw the circle and you can do it. That is also one method. But here, if you know this equation, still you can take the less time now. You can take the less time. But there, it may first you have to draw the circle and everything. But if you know the circle equation, directly can do it now. First question what is given now? Sigma n value how much is given now? 80. Sigma 1 is how much now? 100. Sigma 2 20. And tau s unknown. Directly can calculate it now. Tomorrow class is morning session will be there. Tomorrow will be same timing. Tomorrow the morning class will be there. Draw the Mohr circle for the following state of stresses. So I'm completing the board now. These questions you can complete it. So I'm giving the state of stresses. For this one, you find out the stress on the principal plane, Tomax planes, and planes of pure shear. So all these cases directly can draw it now. Because in all the cases principal stress are known. For the sigma 1 and sigma 2. Sigma 1 is sigma, sigma 2 0. So for the diameter of the circle sigma, radius is sigma by 2. Now for the circle you are going to get tangential to y-axis. For the sigma 1 here, now minus 2 sigma, sigma 2 0. Here for the sigma 1 2 sigma, sigma 3, sigma 2 is what the sigma. So once you know sigma 1, sigma 2, directly can draw a circle. What the shape of the circle is tangential to y-axis on the right side, is the tangential to y-axis on the left side, and the circle will be on the right side of the origin. Here what the sigma 1 and sigma 2 both are equal. So what the Morse circle here now will become a point. Morse circle will become a point on x-axis, positive x-axis. Sigma 1 is sigma, sigma 2 sigma. So what the diameter of the circle? 0. So center is what now? Radius center is diameter is 0 means radius is 0. So Morse circle is a circle with a circle. Morse circle is a circle with what now? Radius equal to 0. Morse circle will become a point on positive x-axis. What the sigma 1, sigma 2? This is the pure shear state of stress. Sigma 1, sigma 2, tau max all are equal to tau. What the tau max? Not tau. So sigma 1, sigma 2, tau max all are equal. So here Morse circle is what now? Sigma 1 is what? A plus tau, sigma 2 is minus tau. So Morse circle is a circle with origin at the center. Diameter will be 2 tau. Radius will be what? A tau. Now this question you cannot directly do it now because principal stresses are unknown. So in this case principal stresses are unknown. So this you can directly draw. You cannot draw the Morse circle. Up to this one directly can draw it because the principal stresses are known. Once you know the principal stress, directly can draw a circle. But the combined stress. So this case only you have to discuss now. But some students are going to use the first they will calculate the principal stress by using the analytical method. You have to draw the circle without the equations. So up to this one directly can draw it, but this question you cannot directly draw it because the combined stress, principal stress are unknown. Principal stress are unknown in this case now. So this question you cannot complete it now. So what the principal stress here now? Sigma 1 comma sigma 2 equal to sigma comma 0. What the practical example? Bar subjected to pure axial loading. So what the diameter of the circle? This is A. What are the coordinates of A? What are the coordinates of B? B coordinates are second principal stress 0. So this will coincide with the origin. Now Morse circle is a circle tangential to y-axis. That's why what you have studied now. Always under uniaxial state of stress. Always under uniaxial state of stress, Mohr circle is going to be tangential to y-axis. So diameter will be sigma, radius will be sigma by 2. Now you can complete the remaining now. Once you know the Mohr circle, you can complete the remaining principal planes, Tomax plane. Now what the stress on the Tomax plane? What the diameter? Sigma by 2. So diameter is sigma, radius will be sigma by 2. These are the Tomax planes. What are these coordinates now? Sigma 1, sigma, sigma 2, 0, sigma and star and Tomax. Sigma and star and Tomax both are going to be what now? Equal, sigma by 2. So well, always in case of uniaxial state of stress, Mohr circle tangential to y-axis. But the sigma is a positive and negative. Positive will come on the right side. Now in this case, Mohr circle is also uniaxial only. Mohr circle is a circle with tangential to y-axis on the left side because sigma 1 is negative. So once again, what the diameter of the circle? 2 sigma. Radius will be sigma. Mohr circle is going to be tangential to y-axis on the left side. So complete the remaining portion now. Tomax planes are always parallel to y-axis. Therefore, what you mentioned, always in case of uniaxial state of stress, Mohr circle is tangential to y-axis, but never tangential to x-axis. On the right side or left side, this is tensile. It's going to be at right side, but this is a negative. It is sigma 1. Sigma 1 is about a minus 2 sigma. So all these are examples are about a bar subject to pure axial loading and pure bending. But pure bending you are not yet discussed. But pure axial loading always a tangential to y-axis. These two are about a pure axial loading and pure bending. So always under pure axial loading and pure bending is going to be Mohr circle is tangential to y-axis. Right side or left side depend upon the sigma 1. Here sigma 1 is positive, but here sigma 1 is going to be negative. Here is the example for thin cylindrical pressure vessel and internal pressure. Hoop stress and longitudinal stress and hoop stress. What the hoop stress here at PD by 2T. Longitudinal stress PD by 4T. So here once again what the principal stresses now. Now both are positive, sigma 1, sigma 2 both are positive. that circle will not intersect the y-axis, but circle will come on the right side of the origin. This example is thin cylindrical pressure vessel under internal pressure. Thin cylindrical pressure vessel, CPV. Cylindrical pressure vessel under internal pressure. So always under cylindrical pressure vessel, internal pressure, more circle is going to be on the right side of the origin, but will not intersect the y-axis. This will be what a PD by 2T. This is PD by 40. Longitudinal stress PD by 40. Hoop stress PD by 2T. This was already written now. CPV means cylindrical pressure vessel. CPV is the cylindrical pressure vessel. If you are not getting the same answer with the Morse circle equation, means somewhere you have done a mistake. Who is Mr. Rajput? Sir, I am not getting the same answer with the Morse circle equation. You should get the same answer. If your Morse circle is what now? Your Morse circle equation not getting the same values of that by using the Morse circle. Somewhere you have done a mistake now. Check your calculations. So here this circle will not give the absolute Tomax. What the radius of the circle? Na sigma by 2. So sigma by 2. What the diameter? Na sigma. Radius is sigma by 2. So this sigma by 2 is not the absolute Tomax. To get absolute Tomax, you have to draw the 3 more circles are required. So what the absolute Tomax? What you studied last class now? Whenever a circle is not intersecting y-axis, it will not give the absolute Tomax. The circle will give only in plane. The circle will give only in plane Tomax. To get absolute Tomax, you draw the other circle. What the radius of this circle? Sigma by 2. What the radius of other circle? Sigma by 2. What the other circle? No, sigma 1, sigma 3 circle, 2 sigma. So one circle diameter is what? Not sigma. Another circle also sigma. Another circle diameter is 2 sigma. So what the in plane Tomax? One is sigma by 2, second one is sigma by 2, other one is sigma. So finally what the absolute Tomax here? No, sigma. Absolute Tomax is going to be sigma, not sigma by 2. Everybody is going to take this radius now. This radius will give the in plane only, clearly mentioned. Whenever a circle is not intersecting y-axis, that circle radius will give only in plane. For design, always you have to go for absolute Tomax. So then you have to draw the 3 more circles are compulsory. Therefore always in your cylindrical pressure vessels or any pressure vessel, thin pressure vessels, to get a absolute Tomax, 3 more circles are required. Here what the absolute Tomax value? No, sigma 1 by 2, that is a sigma. But this circle is giving the what? A sigma 1 by 2 only. What the diameter? 2 sigma. Radius will be sigma by 2. So here 3 more circles are completed. You have to draw it to get the absolute tau max. And what is the example for this now? Thin spherical pressure vessel under internal pressure. The example is thin spherical pressure vessel. Thin spherical pressure vessel under internal pressure. C means cylindrical pressure. CPV means cylindrical pressure. CPV means cylindrical pressure vessel. SPV means spherical pressure vessel. In this case, PD by 40. PD by 40. So here what the sigma 1 and sigma 2. In this case what the sigma 1. Biaxial case always sigma 3 0. So what the distance between sigma 1 and sigma 2? 0. Therefore one circle is becoming a point. Out of all the 3 circles, one circle will become a point. Which circle will become a point? Now sigma 1, sigma 2 circle is becoming a point. More circle become a point on x-axis. So one circle will become a point. Diameter 0 means radius is 0. So when radius is 0 means what? That shear stress 0. Means all the planes shear stress 0. Whenever you want to get a shear stress on any plane, radius is required. But here radius is 0 because diameter is 0. By diameter 0, sigma 1 and sigma 2 are going to be equal. So one in plane tau max 0, one in plane tau max 0. But for design you have to go for absolute tau max. When sigma 1 and sigma 2 like in nature, sigma 1, sigma 2 like in nature means sigma 1 is what? Tau max is sigma 1 by 2. Sigma 1 by 2. So here in plane is 0, absolute is not 0 now. So if we ask for this case what the more circle mean, what the answer now? More circle will become a point on positive x-axis. Suppose these are all negative. These are all negative means more circle will become as what now? Point on negative x-axis. More circle become a point on negative x-axis. If they are negative. But what the maximum shear stress at the point? If it is going to tell 0, sir, more circle is becoming a point. More circle, one circle is becoming a point. Sigma 1, sigma 2 circle is becoming a point. So one in plane tau max 0. What about the other 2 more circles now? Either sigma 2, this is sigma 1, sigma 3. What the diameter of the circle now? Sigma. Radius is sigma by 2. What the other circle? Sigma 2, sigma 3. It is also sigma. So out of the 3 in plane tau max, 1 in plane tau max 0. That is only one circle is becoming a point. Only sigma 1, sigma 2 circle. So if you ask in the question now, what the shape of the more circle means, for this figure it is a become a point on x-axis. Positive or negative depend upon these sigmas now. If they are tensile, it become a point on positive x-axis. If the negative and the negative x-axis. But what the absolute tau max means, it is the sigma by 2. If it is going to try to confuse here only, how absolute tau max sigma by 2. Absolute of sigma by 2. If you draw a circle, is becoming a point. One circle is becoming a point, but not all the three circles now. For this case, if you ask, more circle is a sigma by 2. But how we are getting sigma by 2? How we are getting the sigma by 2 means 3 more circle is required. That only I mentioned last class now. Whenever sigma 1, sigma 2 are going to be like in nature, that circle radius will give only in plane. To get absolute, you draw the 3 circles. Either sigma 1, sigma 2. One circle will become a point. Center of the first circle, center of the circle coincide with the A and B. What the other 2 circle now? Sigma 1, sigma 3. Sigma 1 is sigma, sigma 3 0. For the diameter sigma, radius is going to be sigma by 2. Out of the 3 in plane Tomax, 1 in plane Tomax 0. 1 in plane Tomax 0. Remaining 2 are not 0 now. And for this case, what the principal stresses now? Sigma 1 comma sigma 2 equal to plus or minus tau. So for the diameter of the circle 2 tau, diameter will be 2 tau, radius will be tau. So here only the center will coincide with the origin. So what are these coordinates now? So many times you have studied now. More circle will be what now? Center and origin will coincide. But this you cannot directly can draw it now. Directly more circle cannot be drawn because sigma 1, sigma 2 are unknown. Here More circle cannot be drawn directly because principal stresses are unknown, that is because of the combined stresses. So always in pressure vessels, always pressure vessel, to draw a absolute Tomax, to get absolute Tomax, 3 more circles should be drawn now. But default you have to go for only sigma 1, sigma 2 circle. And for the example you have studied, now shaft subjected to pure torsion. For the practical example you have studied now. Shaft under pure torsion. Show all the planes now, show the principal plane, Tomax plane. I am drawing only the circles now. So this you cannot directly, for this only you have to discuss how to draw it now. But up to this one, what the drawback now? Up to the 5th case, we can draw the circle, we can get the stresses, but plane locations are unknown because reference plane unknown. If I know sigma 1, sigma 2, you can draw a more circle, then you can find out the stress on the Tomax plane and stress on the planes of pure shear. But we cannot get the location because of reference plane unknown, because sigma x and tau xy is unknown now. Now somebody can also locate the reference plane here now. How to locate a reference plane here? Anybody now? In this case, you know the reference plane. Which one the reference plane you have studied? How to locate the reference plane? Sigma x and tau xy. What the sigma x and tau xy? What the sigma x now? Sigma, tau xy 0. So what the that point now? Where the reference plane will lie? Where the reference plane will lie? Here you can also find out the plane locations also. What the sigma x now? Sigma, tau xy 0. So what the coordinates of the stresses, coordinates of the point on the Morse circle corresponding to x phase? What the coordinates of the points? Coordinates of the point on the Morse circle corresponding to stress on x phase. What the sigma x no sigma, tau xy 0. So whose coordinates are sigma comma 0? That is this point now. So directly what the CA is called now? The CA is called the principal plane or reference plane. How to locate the reference point now? We need the sigma x and tau xy. What the sigma x here? No, sigma, tau xy 0. So whose coordinates are sigma comma 0? A. So directly what the CA is called a reference plane or major principal plane. So directly all the angles should be measured from reference plane here now. Or now you can measure all the angles. This is sigma 1. So theta 1 is 0. Here to here what is the angle now? 2 theta 2. So theta 2 0. And here to here what? 2 theta 3. Is the Tomax plane, is the reference plane. 2 theta 3. 2 theta 3 is 90. Therefore theta 3 is going to be 45. Here What the sigma x and sigma tau xy here now? What the sigma x and tau xy? What the sigma x now? 0. Tau xy is also 0. So which one is the reference plane now? Which one the reference plane? The radial line passing through a point whose coordinates are 0, 0. Here which one the reference plane? Now what the sigma x and tau xy? 0, 0. 0, 0. So this point. What this point is called now? This point is giving the stress on the x face. What the stress on the x face? Sigma x comma tau xy. Both are 0. So the radial line passing through this now. What should I call this now? Reference plane. Or sigma 2 plane. In this case, which one is 0 now? Theta 1 is 0. But in this case, which one is 0 now? Theta 2 0. And this angle will be 2 theta 1. Theta 2 is going to be what now? 0. And this will be 2 theta 1. What the 2 theta 1? 180. So theta 1 is 90. So here till what this angle now? So theta 1 is 90 degrees. Theta 1 is 90. But theta 2 is 0. Now here what the sigma x and tau xy? Sigma x is sigma. Tau xy is 0. Sigma x is sigma. Sigma y is 0. So sigma tau xy is 0. For this question, so whose coordinates are sigma comma 0 b. So the radial line passing through b is about now. The radial line passing through a b is about now. Reference plane. So what this line is called now? Sigma 2 plane or reference plane. Now all the angles should be measured from here now. What this line BC or CB? CB is about now. Minor principal plane or reference plane. So all the angles should be measured from here now. In the last class example, directly I taken the principal stress, but here state of stress given. In all these questions, state of stress given. When you know state of stress, you know sigma x and tau xy. What the sigma x? No, sigma tau xy 0. So whose coordinates are sigma comma 0, sigma a. So the radial line passing through C will be the reference point. Therefore all the angles should be measured from CA line. Here what the reference plane now? Sigma x 0, tau xy 0. So whose coordinates are there? The origin. So the radial line passing to the origin, that is the CA line. CA line is the reference plane. All the angles should be measured. Here CB line. In this case, what the reference point now? What the sigma x now? 0. Tau xy is going to be what now? Plus tau. Tau xy is what now? Plus tau. What the coordinates now? So what the sigma x now? 0. Tau xy is tau. Tau xy is what? A tau. So whose coordinates are 0 comma tau here. So now so far in all the questions, reference plane where is lying now? X axis, because tau xy 0. In all the question tau xy 0. So reference plane lying on x-axis. But here which one is 0? Now sigma x 0. So now reference plane will lie coincide with the y-axis. So this line is a reference plane. Now all the angles should be measured from here now. All the angles should be measured from here now. This plane is about a principal plane. So this angle is 2 theta 1. Then theta 1 is going to be 2 theta 1 is about a 90. Therefore theta 1 is going to be 45. So this line is about now. Reference plane or to get the all the angles now, theta 1, theta 2, theta 3, theta 4. To get the all the angles, we need the sigma x and tau x. We should know the reference plane. So in the first three questions now, reference plane lie on x-axis. But here reference plane lie on positive axis. That only are discussed now. Reference plane may lie either on x-axis or y-axis or in a quadrant. But when it will lie on a quadrant, combined stress, in this case, reference plane will lie in a quadrant. What is the sigma x here now? What is the sigma x value now? Sigma x sigma tau xy minus tau. So where this point will lie now, x coordinate is positive, y coordinate is going to be negative. X coordinate is positive, y coordinate negative. Means this point will lie on the fourth quadrant. Now the reference plane will lie in the fourth quadrant. That will clearly mention reference plane may lie on x-axis or y-axis or in any of the quadrant. First three example is lying on x-axis. This example is lying on the y-axis. In this case, it will lie in the fourth quadrant. Sometimes second quadrant, sometimes third quadrant will be there under combined stresses. Whenever both normal and shear stress are there, reference plane lie on one of the quadrant. Now you can mark all the angles. This plane is which plane? Now principal plane is a reference plane. Then what is this angle? Now 2 theta 1. 2 theta 1 is 90, means theta 1 is going to be 45. Is the another principal plane. Here to here, what is this angle now? 2 theta 2. 2 theta 2. So what is the 2 theta 2 value now? 270. Here to here, what is this angle now? 2 theta 2. So 2 theta 2 is 270. Means theta 2 is going to be 135. And what about this line now? Tau max plane. Therefore here to here is that 2 theta 4. So what is this angle now? 180. Therefore theta 4 is going to be 90. Now I am going to discuss this case now. That is combined stress case. Directly we cannot draw the Mohr circle because of principal stress are unknown. Directly in the previous case, all the case principal stress are known. When you know principal stress, directly can draw the Mohr circle now. But in this case, directly we don't know principal stress because of combined stress. And in this case only, the more reference plane lie in one of the quadrant, maybe a first, second or third or fourth quadrant. Here it will lie in the fourth quadrant. Combined stresses. Show all the angles now. This is 2 theta 1. This is a principal plane. 2 theta 3, 270. 2 theta 4, 180. Theta 4 is 180. This line itself reference plane. This line itself tau max plane. So what the theta 3 0. 1 theta 3 0. 2 theta 1 is 90. 2 theta 2 is 270. 2 theta 4 is 180. Right, and the last one. Okay, before this now we'll show. Video stopped. Mr. Anurag Anurag has mentioned video ka no issue. Now this is an important one now. Is the hydrostatic state of stress. In this case, all the three Morse circle will become a point. For the sigma 1 minus sigma, sigma 2 is also minus sigma, sigma 3 is also sigma. In this case, in plane Tomax 0, absolute Tomax 0. But in the previous thin spherical pressure wave case, only one Morse circle will become a point. In that case, only one in plane Tomax 0. But in this case, all the Morse circle will become a point. When all the circles are becoming a point, sigma 1 circle, sigma 1, sigma 2, sigma 2, sigma 3, sigma 1, sigma 3, Morse circle become a point. In this case, in plane Tomax, absolute Tomax, shear stress on all the planes 0. What is the sigma 1 here now? This is only similar to question number 30. Now can you draw the Morse circles here now? Now what the diameter of the sigma 1 and sigma 2 circle? Sigma 1 is also minus sigma, sigma 2 is also minus sigma. So what the distance between sigma 1 and sigma 2? 0. So here all the three more circle will become a point. But in the spherical pressure vessel example, in this case, only one circle is becoming a point. In this case, only one in-plane Tomax 0, absolute Tomax not 0. But in this case, all the three more circle will become a point. Means there is no radius now. What the sigma 1 minus sigma? What the sigma 2 minus sigma comma 0? What the sigma 3 minus? So what the diameter of the sigma 1 sigma 2 circle? 0. Sigma 1 is also minus sigma. Sigma 2 is also minus sigma. So what the diameter of the sigma 1 sigma 2 circle? 0. What the diameter of the sigma 2 sigma 3 circle? 0. What the diameter of the sigma 1 sigma 0? So directly what should I call this point also now? This point itself you can call it as what now? C1, C2, C3. So now more circle will become a point on negative x-axis. It will become a point, and now here so what should I call this distance now? More circle is becoming a point. All the three more circles are becoming a point. Point means what? There is no y coordinate, there is no radius. When there is no radius, there is no y coordinate. When there is no y coordinate, shear stress 0. So here, this distance, what should I call it now? Sigma 1 or sigma 2 or sigma 3 are normal stress on any plane. Normal stress on any plane is same. And all the planes shear stress 0. So this distance itself we can call the what now? Sigma 1, sigma 2, sigma 3, sigma n. What do you join now? The point joining the center to the corresponding point of the circle. The line joining the what now? Origin to the corresponding point of the circle will give the resultant stress. Resultant stress is equal to how much? Minus sigma. So sigma 1 is also sigma. Means all the planes shear stress 0. In this case, so this is a peculiar case. It is a peculiar case. So far you have studied how many principal planes you have studied now? How many number of principal planes you have studied so far now? Only 3 planes. Number of principal planes under triaxials, number of principal planes are 3. But here every plane is a principal plane. Every plane is a principal plane. At a point, how many planes are there now? Infinite planes. On all the planes shear stress 0. Why shear stress 0 now? More circle is becoming a point. More circle a point on x-axis means y coordinate 0. Y coordinate 0 means which one is 0 now? Shear stress 0. So when the shear stress 0 now, all the planes you are going to get only normal stress. So number of principal planes, so far you have mentioned the 3. But that statement is valid what now? Except under hydrostatic state of stress. Except under hydrostatic state of stress. Remaining all the case number of principal planes are 3. But under hydrostatic state of stress, every plane is a principal plane. On this plane, what the normal stress sigma, shear stress 0. On this plane, what the normal stress minus sigma, shear stress 0. On this plane, what the normal stress na sigma minus sigma 0. Like that, you take any plane. Any plane means what? You take any plane at an angle of what? A theta. Even on that plane also, you are going to get the normal stress minus sigma, shear stress 0. Why shear stress 0? Because the point is, circle is becoming a point on x-axis. Whenever you want to get a shear stress, we need a y coordinate. To get a shear stress, we need a y coordinate. To get a y coordinate, radius should be non-zero. Radius should be non-zero. If the radius should be non-zero, means sigma 1 and sigma 2 should be unequal in magnitude. Unequal in magnitude or unlike in nature. But whenever sigma 1 and sigma 2 are equal and like in nature, equal and like in nature, here sigma 1 is also minus sigma, sigma 2 is also minus sigma. So whenever the principles are equal and like in nature, then diameter will be what? Become 0. Diameter 0 means radius 0. When radius 0, shear stress 0. But like this, what? All the circle becoming a point. So if somebody will ask how many number of principal planes are there, mean what the answer? No. Number of principal planes are 3 except under hydrostatic state of stress. But under hydrostatic state of stress, principal planes are what? No, infinite. Every plane is a principal plane. So here only the bulk modulus definition is valid now. Though they have studied what a homogeneous isotropic, I written the definition of Young's modulus, shear modulus, bulk modulus. The bulk modulus definition valid only in this case. Young's modulus under uniaxial state of stress, biaxial pure shear state of stress. But the bulk modulus valid in case of hydrostatic state of stress. If somebody will ask, how do you know every plane is a principal plane? Therefore, in this case, only volume will change or distortion will occur. No, only volume will change. Because on all the planes shear stress 0. Whenever you want to get a change in shape, we need a distortion required. We need a shear stress. To get a shear stress, y coordinate required. To get a y coordinate, radius should be non-zero. If the radius is non-zero, y coordinate is non-zero. When y coordinate is non-zero, shear stress non-zero. Then distortion will be there. But here only volume will change. The cube will remain as a cube, but only the volume of the cube is decreases. But there is no distortion. Whenever you want to get a distortion, there should be a shear stress. Everybody is asking the question number 30. Everybody is asking the question number 30. What is the question number 30? A two-dimensional fluid element rotates like a rigid body at a point within the element. The pressure is 1 unit, radius of Mohr circle. Pressure means what? Always the hydrostatic pressure, and all the direction pressure is same. Same thing what now? What the normals in all the direction? Minus sigma. Here x direction how much? Minus sigma. Y direction how much? Minus sigma. Z direction also minus sigma. And even at an angle of theta is also minus sigma. Why no? Why all are equal? Because shear stress 0. Why shear stress 0? No? Radius is 0. But in this case, spherical, in this case what happens now? In this case only one in plane, only one more circle is 0. But here sigma 3 is 0. But here sigma 1 is what? A sigma. Sigma 2 sigma. Only sigma 1 and sigma 2 are equal and like in nature. In this case only sigma 1 and sigma 2 are equal and like in nature. But sigma 3 is 0. Therefore here only sigma 1, sigma 2 circle will become a point. So only one in-plane Tomax 0. Remaining two in-plane Tomax are non-zero. We are going to get a one more circle. What is this circle now? Sigma. What the other circle? Sigma. Diameter sigma. Radius is sigma by 2. So in this case, one in-plane Tomax is 0. Remaining two in-plane Tomax are non-zero. So here absolute Tomax is what? A sigma by 2. It is not a hydrostatic state of stress. Hydrostatic state of stress means what now? What the meaning of hydrostatic state of stress? Normal stress in all the directions. That is what now? X, Y, Z direction. When the normal stress in what now? X, Y, Z direction are equal and like in nature. When normal stress in three mutual perpendicular direction equal and like in nature, then at that time even the normal stress at an angle of theta, it is also 0. Sorry, minus sigma will be there now. Then in that case, in plane Tomax, absolute Tomax, tau s is 0. Only volume changes. So you should be careful now. How many number of principal plane means answer is what? 3. Except under hydrostatic state of stress condition. Except under hydrostatic state of stress condition, number of principal planes are 3. But under hydrostatic state, every plane is a principal plane. How do you know it? You can explain the 2 ways. Under hydrostatic state of stress, why every plane is a principal plane? That is why principal plane lies in all direction. 2 ways you can explain it. What the first method now? All the 3 more circles, sigma 1, sigma 2 circle, sigma 2, sigma 3 circle, sigma 3, sigma 1 circle will become a point on x-axis. When the circle is becoming a point on x-axis, there is no y-coordinate. When there is no y-coordinate, that is the no radius. No radius means no y-coordinate. When there is no y-coordinate, there is no shear stress. So on all the planes, this is nothing but a resultant stress. Resultant what? A sigma 1, sigma 2, sigma 3, sigma n at an angle of theta. Resultance is an angle of theta equal to minus sigma. Otherwise, you can use the equations also. You can use the sigma n and tau equation also. First, assume the point belongs to x and y. First, assume that because our equations are valid for biaxial. First, assume the point belongs to x and y. Then use your sigma n and tau equation. We are going to get this now. You can use your sigma n and tau equations also. What the sigma x now minus sigma. What the sigma y minus sigma. Tau x y 0. You can use your sigma n and tau equation also. Then you are going to get sigma n equal to minus sigma. What the meaning of this now? Theta will depend upon theta or independent of theta. Theta is what? Sigma n is the independent of theta. Independent of theta means on all the planes it is going to be same and shear stress 0. Either you can explain with a more circle will become a point on x-axis. Positive x-axis or negative x-axis. If this is a negative, is a compressive on negative x-axis. By chance is given as a positive, then it will lie on positive x-axis. Otherwise, you can use your sigma n and tau equation also. First, assume this point belongs to x and y. What the sigma x minus sigma? What the sigma y minus sigma? Tau x y 0. Then you can check it now. You are going to get the sigma n equal to minus of sigma means sigma n equation independent of theta. Independent of theta means on all the planes the value of the normal stress same and shear stress is going to be 0. Distortion. Whenever you want to get a distortion, what is required? Shear stress required. In this case only, maximum shear stress theory and maximum distortion energy theory are not valid. Maximum shear stress theory and maximum distortion, there is no distortion, only volume will change and there is no shear stress. When there is no shear stress, we cannot use the maximum shear stress theory. So in this state of stress condition, maximum distortion energy theory and maximum shear stress theory are not valid. Maximum shear stress theory and maximum distortion energy theory are not valid. And in this case only the bulk modulus definition is valid. What the bulk modulus definition now? This here written a bulk modulus now. Why this minus sign now? Bulk modulus should be a positive. Bulk modulus should be a positive. Or sigma directly. Now this sigma is called as what now? Hydrostatic stress. Hydrostatic stress. So bulk modulus is what? A ratio of hydrostatic stress to volumetric strain. And this definition valid only under hydrostatic state of stress. So once again I am concluding now. Just now I explained everything. Why you are asking about all this thing? Sir, please explain it. Just now I explained, no? For that only I explained here now. Srivastava, are you listening or not? Same thing I have explained. You are asking what now? Why you are asking now? Somebody about a 13 explain, 14 explain. In place of explanation only I have taken all these cases now. Are you listening or not? All these questions I have explained here now. Please means what I have to do it now. In place of that questions only I am doing all these questions now. There are all direction means only x and y plane. You have to assume it now. In the question 14, none of them are what now? 0, 90 is not possible. 90, 0 is not possible. 45 and 135 is not possible. So all direction should be there now. All direction means in xy plane all direction. Xy plane all directions. Only in xy plane all direction, not in all the xyz faces. I am explaining what everything what now. Because you are all getting, somebody is asking 13, 14 and 30. That's why I am discussing all these questions now. And once again you are asking, sir, please, what I have to do it now? With this one you try that questions now. Here principal plane lies in all directions. Principal plane lies in all direction means, I am talking about the triaxial case, not only x and y face. X and y plane, y and z plane and z and x plane, all the planes. Is the triaxial. What is the maximum value for theta? 360 degrees. This is what now? This is what now? Plane stress case. Now, it is not a triaxial. Is it triaxial or biaxial? It is a triaxial or biaxial case? Biaxial case. In this case, the plane within 0 to 180 degrees. 0 to 180 degrees. 0 to 180 degrees. Every plane is a principal plane. Not 0 to 360 degrees. 0 to 180 degrees, every plane is a principal plane. Is a biaxial. Biaxial means what? The maximum value for theta is what now? 0 to 180. 0 to 180. is the triaxial case. What the maximum value for theta? 0 to 360 degrees. So here 0 to 360 degrees on all the planes, shear stress 0. Here 0 to 180 degrees only. 0 to 180 degrees only. All the planes are principal plane. Only x and y. What is the value of this now? This is about a question number 13 and 14. This question only about now 13 and 14. Just now you have studied the thin spherical pressure vessel under internal pressure. This is a 2D or 3D case? No, 2D. Sigma z is 0. It is a 2D. That is a 3D. It is a biaxial case. Here, every plane is not a principal plane. The planes in 0 to 180 degrees. The planes from 0 to 180 degrees is going to be every plane is a principal plane. 0 to 180 degrees. But here, 0 to 360 degrees, every plane is a principal plane. 0 to 360 degrees. But here, only 0 to 180 degrees is a plane. Plane means what? A 2D. Is a x phase, y phase. Means you are cunning only in the x and y, not on z phase now. We are not considering z phase. That is not 0 to 360 degrees. So like this, what on this plane now? What the normal stress now? Sigma. Even you take like this now, in on this plane also, what the normal stress now? This is what a 2D or 3D? 2D. Is a biaxial case. Sigma 3 is, sigma z is 0. It is a biaxial case. This is only what a thin spherical pressure vessel under internal pressure, as well as what now? Question number 13 and 14. Here only one more circle will be point. One more circle will become a point on x-axis. In this case, the planes between 0 to 180 degrees, the planes lying between 0 to 180 degrees, every plane is the principal plane. But here 0 to 360 degrees, 0 to 360 degrees. So here this is what x phase. Like this, how many planes are there like this now? Infinite planes. Like this, infinite planes are going to be there now. What the normal stress on this plane? Sigma. On this plane, what the shear stress 0, what the normal stress sigma? At an angle of theta, normal stress sigma, shear stress 0. So on all the planes, shear stress 0. But this is only 0 to 180, is a biaxial state of, but that is what now? Triaxial state. In this case, what the maximum value for theta? Sigma 1, sigma 2 plane means what? A 0 to 180 degrees. So we are considering only stress on x and y phase, means here theta value is what? A 0 to 180 degrees. But there, 0 to 360 degrees. Therefore, there, if you take any plane from 0 to 360 degrees, on all the planes, shear stress 0. But here, shear stress 0 only on the plane from 0 to 180 degrees. 0 to 180 degrees, not 0 to 360 degrees. So this is what now? Some theta 1. Theta 2. Here only one more circle become a point. Only sigma 1, sigma 2 circle is becoming a point. Only one more circle becoming a point. Other two circles are not becoming a point. Therefore, here only on the plane from 0 to 180 degrees, in the plane of x and y, only in the plane of x and y shear stress 0. But the plane between 0 to 360 degrees, not about the principal planes now. So like this you take it what now? When theta 1, theta 0, what the normal stress sigma? Theta 1 is also sigma, theta 2 is also sigma, theta 3 0. So like this you take any plane from 0 to 180 degrees. You take any plane from 0 to 180 degrees. On all the planes shear stress is going to be 0, only normal stress will be there. What the normal stress value in a sigma, but there 0 to 360 degrees and all the plane normal stress is sigma and shear stress is 0. Here only one circle is becoming point. In this case, but what about the other two circles? Now this is what now? Sigma 2 and sigma 3 circles. Only one circle will become a point here now. That is only the planes in the x and y. Only the planes xy plane, that is what? The x face, the y face. 0 to 180 degrees, every plane is the principal plane. But not from 0 to 360 degrees. But that is about a triaxial, where maximum value for theta is going to be 360 degrees. Whether maybe a sigma may be a positive or negative, whatever it is now, need not be a compressive. Need not be a compressive. Maybe a positive or negative. I taken the negative because generally pressure is what now? You can take it as maybe a positive also, you can take it now. So these are all what now? Like this, all are principal plane. Here what the maximum value for theta? That is in the plane of x and y. But in this case, like this what now? If you take any plane in x and y, y and z, x and z. Here x and y, if you take x and y or y and z or x and z. So take any plane in the x and y or y and z or x and z. All the plane you are going to get like that now. So here this only what now? Hydrostatic state of stress. Here only this is what? That is not a hydrostatic, the biaxial. There sigma z is not sigma. Sigma z is 0. But here sigma x, sigma y, sigma z all are equal now. So in the question number 14, all direction means you have to assume that what now? Since the 2D, that question is the 2D, means you have to assume the any plane in between 0 to 180. All the planes mean what now? You have to assume the any plane between 0 to 180. But that is the triaxial. There the maximum value for theta 360 degrees. Now can you make a comparison between these two now? This is what now? For the practical example now, thin spherical pressure vessel under internal pressure. Thin spherical pressure vessel under internal pressure. So this is a triaxial state, but this triaxial state of stress known as a hydrostatic. But this is a biaxial state of stress. Here the maximum value for theta is going to be 0 to 360 degrees. But here maximum value for theta is what now? 0 to 180 degrees. Only in the plane of x and y. Here all the three more circle will become a point on positive x-axis. Here only one more circle will become a point on x-axis. Remaining two circles are not a point. Now here in plane Tomax, absolute Tomax, shear stress on all the planes 0. But here only one in plane Tomax 0. Only one in plane Tomax 0. Absolute Tomax is not 0. Absolute Tomax is not 0. And here you take any plane between 0 and 360 degrees. All are principal plane. But here only the plane between 0 to 180 degrees. That is in the plane of x and y, the principal plane. Here only volume will change. Distortion will not be there. But here it is a 2D. It is a 2D. It is not a hydrostatic state of stress. In this case, distortion will also occur now. Distortion will also occur. Distortion will also occur now. So these are the differences now. Sigma x, sigma y, sigma z are equal and like in nature. Biaxial state of stress. This is biaxial state of stress. Biaxial state of stress. MSST means maximum shear stress theory. Maximum shear stress theory, maximum distortion energy theory are not valid. And here maximum shear stress theory and maximum distortion energy theory are valid. So these are the differences now. Probably first time I written all these differences in your batch only now. So many friends are getting a doubt now. Examples are what? When thermal expansion is restricted in three mutual perpendicular direction, but at that time sigma x, sigma y, sigma z are going to be minus sigma. Maybe this is a plus sigma or minus sigma. I taken the plus sigma, but when the temperature expansion is restricted, then it's going to be a compressive. Similarly, when a body is immersed in a fluid, it is also going to be, pressure is acting just like a compressive now. And this is what a thin spherical pressure, internal pressure, sigma x, sigma y equal to hoop stress PD by 40. But here theta, what the theta? Theta value is how much? 0 to 360. Here theta value is what? 0 to 180. So if you take any plane between 0 to 180, what the normal stress? No, sigma. So your principal plane lies all the direction means 0 to 360, but here all direction means principal plane lies all direction means 0 to 180 degrees. Maybe a tensor may be compressive, already mentioned my dear friend. Maybe a tensor may be compressive, need not be always a compressive. In these two examples, it's going to be a compressive. Thoda listen properly. Without listening, don't ask the questions now. That may be a positive or maybe a negative, anything is possible now. Maybe a positive or maybe negative, all are possible now. But in this example, it is going to be a negative, you are going to get it now. Need not be a positive, need not be a negative. Sometimes it's also positive, is also going to be there now. A cube pulled in all the three direction with a P. Now what the stress now? Area of all the faces are same. Now in this case what the sigma x, sigma y, sigma z? In this three example it's going to be a negative. But in this case what now? All the areas are same. A cube is going to be pulled in x direction P, y direction P, z direction P. Don't assume what now directly now. Sir, hydrostatic means compressive, sir. Maybe a negative or maybe a compressive positive will be there now. In this case, what you are going to get it now? Is a cube. Sigma x equal to sigma y equal to sigma z is equal to p by a square. But if you apply a compressive load, it will become as a compressive. Stress nature will depend upon the load now. But when expansion is restricted, then you are going to get what now? When expansion restricted in all the three directions, then at that time it is going to be a compressive load is going to be there now. When thermal expansion restricted, then at that time the reaction will act as a compressive load. Then you are going to get a minus p by a square. So this may be a positive or negative depend upon this p. Suppose you are applying a tensile load p by a square, positive. If you apply a compressive load, it will be what now? So many times I mentioned now. Stress will depend upon the applied load. Mr. Abhishek Jai Shankar, please listen properly. In these two examples, that's why I written as a minus, I written here now. In these two examples, you are going to get a minus. When expansion is restricted, as well as what a body immersed in a fluid, then you are going to get a minus, you are going to get it now. But sometimes the very standard objective questions are there in the engineering service paper like this now. It's a very standard objective question now. If you refer the engineering service papers now, probably in one of the gate papers also given. And one question is asking what now? This question given in gate and civil also, same year. The same question given in gate paper, civil engineering paper, mechanical engineering paper, same question. In mechanical engineering paper, they ask what the normal stress on this plane. And civil engineering paper, they ask what the shear stress. Now here what now? 0, this is just the same example now. 0 to 180 degrees, every plane is a principal plane. Means on this plane, what the normal stress? No, sigma shear stress 0. So if you remember this one directly, you can give the answer now. 0 to, this is only taking the x and y. Same thing what hydrostatic means. This is only x and y. Hydrostatic means you have to take the y and z and x and z also. So here directly what the normal stress? No, sigma shear stress is 0. So it asks, one question is asked, what the normal stress at an angle of theta. Another plane is asked, another question, what the shear stress at an angle of theta. This so many times repeated now. What the normal stress at an angle of theta. Sometimes theta value is also given. Theta 30 degrees or 40 degrees are going to be given. And it asks what the normal stress. Directly what the answer? No, sigma. And directly what the shear stress? 0. What the answer for this question? Directly sigma. We are doing only for biaxial. Same thing hydrostatic means what? You have to take the x and y, y and z and x and z, all you have to consider now. Here MSST means maximum shear stress theory. MDET means maximum distortion energy theory. And the bulk modulus definition valid only under hydrostatic state of stress. Bulk modulus definition valid under, in this case bulk modulus definition not valid now. Bulk modulus, if you want you can write down one more difference now. Bulk modulus definition is valid. Bulk modulus is valid. Here bulk modulus concept is not valid now. So bulk modulus should be only used under hydrostatic state of stress. In this case, bulk modulus is not valid now. I will try to upload that conclusions mostly by tomorrow, more circle conclusions. Quickly write down the last one. Steps used to draw a Morse circle. Draw the graphical representation of biaxial state of stress. Next, draw x and y axis. Draw sigma and tau. So represent sigma and tau along x and y axis respectively. Next, locate a point. Capital A such that locate a point A corresponding to state of stress on X face. State of stress on X face. That is locate a point B corresponding to state of stress on Y face. Now all the questions, whatever you are done with the analytical method, now you can use this with this method. And in this method, without knowing this method is valid for any case now. But previously you have done it, directly you have drawn the Mohr circle when you know the principal stress. But here, without knowing the principal stress also directly can draw it now. Join the points A and B and bisect line AB and bisect the line AB. Considering bisection point C as and radius is equal to CAR CB and radius equal to CAR CB. Draw a Mohr circle. All the plane inclination should be measured from radial line CA. That is because of what now? It is the reference plane. Reference plane means X phase. So in this case, what happens now? We can find out the stresses and we can find out the location also. We can find out the stresses as well as the location also. Last class, whatever the questions you have done it, directly Mohr circle is given, then you can find out only stress on the all the plane, but we cannot find out the location because of sigma x and tau x phi is unknown. So if you know this now, so once you know circle now, you know how to do all the calculations now. Last class you already done what so many questions you have done it. Once a circle is given, now we have discussed how to draw the circle and from where you have to measure the angle also. Angle as per our notation, all the angles are measured from X phase. X phase means reference plane. In this case, what the reference plane now CA. What the A is representing now? A is representing state of stress on X phase. That is sigma x comma tau xy. So now for this case, now you can draw the more circle now. Now for this case, if the question is given like this, which for this given state of stress, which Morse circle is correct? Suppose if the 6 more circles are given now, for this given state of stress, which Morse circle is correct? If it is the MSQ question, which of the following Morse circle is or are correct? Which of the following Morse circle is or are correct for the given state of stress? Three friends have given the answer now. Mr. Manas, Ram Kumar Sharma, Rajan Shu. One more option is cannot be decided. Cannot be decided because numerical values are unknown. Cannot be decided. Some friends are going to give the cannot be decided because the numerical values are unknown. BND, Anurag Yadav, Satyendra Kumar, DEB, Ashish Kumar E, Sinha C, BND, E. So most of the friends have given the correct answer, but few friends are given the incorrect now. Answer is D. So this is a practical example why I kept the triple star. Triple star. Why I kept the triple star? All the machine component, this type of state of stress is going to be there. Entire your machine design, you are going to get this type of state of stress. Is a practical example. So many examples will be there now. If I make this sigma by 2 0, if I make this sigma by 2 0, only sigma is there for a pure axial loading. And if I make this sigma is 0, only sigma by 2, pure torsion. Axial load, bendiment and twistingment. Bendiment and twistingment. Like this, what now? All the examples. Entire machine design. Total machine design, you are going to get this example only. And when you are going for the beams, inner fibers of the beams. Inner fibers of the beam. Somebody is giving E. How it is E is possible? E is possible only under uniaxial state of stress. So what the conclusion now? What the specialty of this now? Is a combined stress. Is a combined stress. Is a combined stress. But what the specialty now? Normal stress in one direction is 0. So remember what now? Under biaxial combined stresses, that is what now? When normal stress in one direction, biaxial stress means two normal stress are there, sigma x and sigma y. So under biaxial combined stress, when normal stress in one direction is 0, that is either x direction or y direction, either x direction or y direction. If normal stress in either an x direction or y direction is 0, always a Mohr circle is going to be unsymmetric about the origin. Unsymmetric about the origin. So which one are unsymmetric about origin? B and D. But this is what now? Symmetric about the origin. This is possible only when now? When sigma x plus sigma y 0. This f is possible. Somebody also selected f. F is possible only when sigma x plus sigma y 0. And this is generally possible under uniaxial state of stress. So under biaxial combined stress, when normal stress in one of the perpendicular direction is 0, either x direction or y direction is 0, Mohr circle always unsymmetric about the origin. Unsymmetric means either B or D should be correct. Either B or D should be correct. Then how to eliminate it now? See this sigma. This sigma is a tensile or compressive. Tensile means tensile portion should be more, means right side portion should be more. Suppose by chance this is given as a compressive. By chance this is given as a compressive. Then option B is correct now. Under biaxial combined stress, when normal stress in one direction is 0, that is sigma by 0. Now sigma x. If the sigma x is a tensile, sigma x is a tensile, then this is correct now. Sigma x is a compressive, then this is correct now. When either sigma x or sigma y is 0 and tau xy is non-zero. What the first conclusion now? First conclusion is Mohr circle is unsymmetric about the origin. Mohr circle is unsymmetric about the origin. Mohr circle Next, principal stress are unlike in nature. Unlike in nature. Sometimes the same question will be like this now. Principal stress, for this case they will ask in place of Mohr circle. The theory question will be there now. Mohr circle, principal stress are both are like in nature. Both are unlike in nature. Both are tensile, both are compressive. One is a tensile, one is a compressive. What the answer now? They are unlike in nature. Principal stress are unlike in nature because Mohr circle is intersecting the y-axis. Then, what the conclusion now? In plane tau max and absolute tau max are equal. In plane tau max and absolute tau max are equal. So in this case, directly this circle radius will give the absolute tau max. That's why in the entire machine design, they are taking the tau max is sigma 1 minus sigma 2 by 2. All the students are going to ask now, sir, you have mentioned design, you have take the absolute tau max, but in all the machine design textbook, my machine design teacher is also taken sigma 1 minus sigma 2 by 2, sir, they have taken in plane tau max, but you have mentioned You have to take a absolute tau max, sir, but all the textbook, even standard textbooks also, they are taken in plane tau. Why they are taking the in plane tau max? Because in plane and absolute both are same. When in plane and absolute both are same, when unlike in nature, when they are going to be unlike in nature now, whenever normal stress in one direction is what now? 0, and tau xy is non-zero. More circle is unsymmetrical origin. Principal stress are unlike in nature. In plane tau max and absolute tau max are equal. Then only you have to decide what, based upon this one, either B or D is going to be correct now. Either B or D is correct. Then how to identify the B or D now? Only one normal stress is there. One normal stress 0. One normal stress 0. If that normal stress is what now? Tensile. Then B, D is correct. If that normal stress is what now? Compressive now. Then it is going to be C is correct, B is correct now. By chance this is given as a compressive. Then B is going to be correct now. So in all these cases, in all the, now see the P, the tensile load or compressive load? Tensile load. So in all these cases, 1, 2, 3 as well as the inner fibers of beam, either B or D is possible. Either B or D is possible. But here P is already a tensile load. P the tensile load. Then D is correct now. But if the P the compressive load, then B is going to be correct now. Suppose here sigma y is also given, then you cannot directly tell it now. Directly we cannot tell it. You have to draw it now. But in this case you cannot draw it. You need not draw it directly, can tell it now. But suppose here this is given as sigma by 2. This is given as a sigma by 2. Then we cannot directly decide it now. Maybe in that case A may be correct, or B may be correct, or C may be correct, or D may be correct. Then you have to do, you have to draw the diagram, otherwise you have to do the principal stress calculations now. Suppose sigma y is also there. Suppose sigma y is given what now? 2 sigma is given now. Then in that, or sigma y is given some sigma by 2. Then in that case, we cannot directly decide it now. There you have to draw, or you have to calculate the principal stress and you have to decide it. But in this case, directly can decide it now. Some students are what a majority has given the option D. Some students are selected E, some students are selected F. F is possible only under pure shear state of stress, and generally E is possible under uniaxial state of stress. Now can you draw it now? What should be the first step you have studied now? Draw the x-axis and y-axis. Then you need the coordinates now. This is representing what now? This is x face, or you are calling as a reference plane, because all the angles are measured from here now. Y face. Anybody what the other name for y face here now? Plane of pure shear stress. On this plane what? A normal stress 0, shear stress non-zero. Therefore this plane is called as what now? Y face is known as what now in this case? Plane of pure shear stress. But what about this plane now? It is not a plane of pure shear stress. But this is a plane of pure shear stress. Why now? Because of normal stress 0 and shear stress is there. But this plane is a principal plane or tau max plane? No. It is not a neither principal plane nor tau max plane. When this will become the tau max plane? When sigma x and sigma y are equal and like in nature. Suppose this sigma y is also sigma, then at that time this is going to become as a Tomax plane. But this is what now in this case, neither you don't know principal plane nor Tomax plane. Neither simply it is called as what now? X face or reference plane. RP means reference plane. Reference plane. Most of the students they are going to take the plane, sir, is the plane of pure shear means also they are not complementary planes. Now what should be the first step now? A coordinates. What are the A coordinates now? Sigma x comma tau xy. What are the sigma x now? Sigma. What are the tau xy? Sigma by 2. Next, what the B? Sigma y comma minus tau xy. What the sigma y? 0. Now where this A will lie? First quadrant. B will lie on what now? Negative y-axis. Since A is lying on what? The first quadrant, therefore reference plane will lie in the first quadrant. What you have studied, reference plane may lie either on x-axis, y-axis or in any of the quadrant. In this case, reference plane will lie in the first quadrant. And the B will lie on what now? Negative y-axis. So if we join A and B, automatically more circle will intersect it now. So this point will lie on first quadrant. Lie in first quadrant, but B will lie on what now? Lie on negative y-axis. So when the A lie in first quadrant means reference plane will lie on the first quadrant. Then you can do the remaining now. What is the A coordinate now? This is how much now? Sigma. So what is this A coordinate? Sigma comma sigma by 2. Next, where the B will lie? B lies on negative y-axis. B will lie on negative y-axis. Then what is the next step now? Join A and B. Join A and B. This height is minus sigma by 2. This height is sigma by 2. So these are the two similar and identical triangles. This triangle and this triangle are identical triangles. So directly this will become the bisection point. So wherever this line AB intersect the x-axis, wherever the line AB intersect the x-axis will become the bisection point. Bisection point, that will become the center of the circle. That will become the center of the circle. Now you can take the CA as a radius or CB as a radius. Now what the radius value? Now this total distance, how much? Now sigma. So this distance sigma by 2, this sigma by 2. This total distance here to here, how much? Now sigma is a sigma by 2. Therefore this will be sigma by 2, sigma by 2. So what the radius value now? Sigma by root 2. So once you know the radius, which one is known now? In plane Tom axis is known. Here to here, what is this total distance? Now sigma. So the midpoint. Therefore this is sigma by 2, this is sigma by 2. Already this distance sigma by 2. So the radius is what? A square root of sigma by 2 whole square plus sigma by 2 whole square. Radius is known. Now you can draw a circle now. Now what should I call this CA line? What should I call the CA line? X face. This is the sigma x and tau x phi. Now this will be the reference plane. All the angles theta 1, theta 2 up to theta 6, they should be measured from the CA line. They should be measured from the CA line. Now taking C as the center, CA as the radius, draw a circle now. So once you know the circle, you know remaining all the procedure now. Now this circle is intersecting x-axis or y-axis both. Now which side portion is more? Now right side portion is more now. Now once you know this, what the first step now? Once you know the circle, what should be the first step? You have to identify where circle is intersecting x-axis. Always the circle will intersect the x-axis at the 2 points. This is D, E. Now D coordinate is more or E coordinate is more? D. Therefore D coordinate is representing sigma 1. And E coordinate is sigma 2. Now this will be the sigma 1 plane or maximum tensile stress plane. And what about this line now? This line is a reference plane or x face. X face or reference plane. So now this angle will become the 2 theta 1. This angle will become the 2 theta 1. Now can you find out the 2 theta 1? What this height? No, sigma by 2. This is also sigma by 2. Therefore 2 theta 1 is 45. So theta 1 is 45 degrees. So you know the location of major principal plane. What this distance? Sigma by 2. This is also sigma by 2. So 2 theta 1 is 45. Therefore theta 1 is 45 degrees. Once you know theta 1, now you can find out all the angles. Now to find out the sigma 1. Sigma 1 equal to OD. How to find out the OD? OC plus CD. What the CD now? Radius. Radius is sigma by 2. And what about the OC? Sigma by 2. This total distance sigma, this is sigma by 2. This is the radius sigma by root 2. So what the sigma 1 value? No, sigma by 2 plus sigma by root 2. So like this you can do all the calculations now. Sigma 1 is equal to OD. OD can be written as OC plus CD. That is sigma by 2 plus sigma by root 2. And theta 1 is how much is now? 2 theta 1 is 45. Hence theta 1 is 22.5. Without using any equation you can complete it now. Next, what about the sigma 2 plane? This is another principal plane or compressive stress plane. This plane is about now sigma 2 plane or compressive stress plane, maximum compressive stress plane. Now what the sigma 2? Sigma 2 should be written as minus of OE. How to write in the OE now? CE minus OC. So that is OC minus CE. What the OC value now? Sigma by 2. And radius is sigma by root 2. How to check it whether these values are correct or incorrect now? Summation of sigma x plus sigma y should be sigma. So principal stress sum is what now? Sigma 1 plus sigma 2 equal to sigma x plus sigma y. Sigma x sigma y 0. So sigma 1 plus sigma 2 equal to sigma. If I add these two, you should get the sigma now. And what about 2 theta 2? This is the x phase. This line is the sigma 2 plane. So here what this angle now? This is a 2 theta 2. 2 theta 2. Already this angle is what? A 45. And here what the angle of 180. So 45 plus 180, 225. So 2 theta 2 is 45 plus 180. So theta 2 will be so we can get the principal stress and the location also we can get it now. So remaining you can do it now. How to get the tau max plane now? Tau max planes are the radial line parallel to y-axis. What this coordinates now? Sigma by root 2. That is sigma and star tau max. Tau max means both in plane and absolute both are same. Once again, what this g coordinates now? Sigma by 2 sigma by root 2. Now this line is about now 1 tau max plane. So here what this angle now? 2 theta 3. 2 theta 3. So this is 45 and this is 90. 45 plus 90, 135. Therefore, theta 3, 67.5. Sigma and star is equal to OC. In plane tau max, absolute tau max equal to radius and what the 2 theta 3, 45 plus 90, $67.5. And this is another tau max plane. This is another tau max plane. So like this, you can do the remaining all now. This will be about now. Another tau max plane. So here what this angle now? 2 theta 4. 45, 90, 90, 90. Already this is 45. 45 plus 90, 90, 90. 270 plus 45. 315. So 157.5. You can check it all the angles now. Theta 4, 2 theta 4. Therefore, what all the angles you want to get it reference plane. How to locate the reference plane? Whose coordinates are sigma x comma tau xy. What the sigma x? No, sigma tau xy sigma by 2. A coordinates are representing the stress on x face. What the A coordinates are representing stress on the x face. So the radial line passing through A is a reference plane. So one direct, that's why I have given clearly in the conclusions as a procedure now. CA line will become the reference plane or the x face. All the angles should be measured from that x face. $157.5. Now you look at the planes of pure shear. This is one plane of pure shear. This is one plane. How to locate the plane of pure shear? Where the circle is intersecting y-axis. This is one point of intersection. And this is another point of intersection. And B and H coordinates are same. B and H coordinates are same. Already what the B coordinates 0 comma sigma by 2. So this coordinates also 0 comma. So directly this will represent the tau S star. From here itself we can tell it now. Directly this tau yx will become the tau S star in the plane of pure shear. But the plane of pure shear is studied on this one, normal stress 0, shear stress non-zero. This is the normal stress 0 in the plane of pure shear. Plane of pure shear. Therefore directly this sigma by 2 will become the tau S star plus or minus sigma by 2. So this line will be about now. Plane of pure shear stress. Now here what this angle of 180 is a reference plane, is a plane of pure. What this angle here 180. So 2 theta phi is 180. Therefore theta phi is 90. So 2 theta phi. Theta phi is 90 degrees. Theta phi is 90 degrees. What the other plane of pure shear? CH. What the other plane of pure shear? CH. Is another plane of pure shear. Now can you get the 2 theta 6? Now here to here, this is another plane of pure shear, is a reference plane. So here to here, I am not showing the 2 theta 6 because already number of lines are more. So here to here, from line CA to the angle between CA and CH. CA is the reference plane. CH is the another plane of pure shear. So here to here, this angle is 2 theta 6. How to find out? Already up to 2 theta phi. What the angle of 180? So 2 theta phi plus you have to add this angle now. What this angle now? This height is how much now? This height is sigma by 2. Is also sigma by 2. This height is sigma by 2. This is also sigma by 2. So what this angle now? 45 degrees. This is sigma by 2. This sigma by 2. Means tan theta is 1. Means 45. This is a 45. This is a 45. So already up to this one 180. 185 plus 180 plus 90. 185 plus 180 plus 90, 270. So 2 theta 6 will be now you can see now they are not complementary planes, but remaining planes are complementary. Angle between theta phi and theta 6 not 135 degrees. Only the theta 6 are not shown now. The angle between CA and CH, the angle between CA and CH will be about now. Angle between CA and CH is 2 theta 6. Up to this one is 2 theta phi. Now we have to add this angle now. This height is sigma by 2, this is also sigma by 2. So this angle is 45, this is also 45. So 2 theta phi plus 90. So theta 6, 135. Now like this, what now? You can get now without using any equation, you can get it sigma 1 and theta 1, sigma 2, theta 2. Sigma n star in plane tau max, theta 3, theta 4, tau s star. So whenever you want to get the reference plane, whenever you want to get the theta 1, theta 2, theta 3, theta 4, theta 5 or any angle, we should know the reference plane. If we should know the reference plane, we should know the sigma x and tau x phi. Once you know sigma x and tau x phi, we can locate a point such that it is corresponds to sigma x and tau x phi. So once you locate that point, then join that point to the center. That radial line will become the x face. That radial line will become the x face. So draw the circle like this, what now? So finally, in the exam, whichever is going to be what a convenient that you can use it now. But for some question today, whatever the question you have done it, starting now, that questions should be always solved with the graphical method only. Some questions always more circle is better now. So this question is up to you. In objective examination, they will not mention any method. Even if this question what now? Find out the principles, so they will not mention any method. Those you are thorough with the analytical method, you can use that now. Those you are thorough with the more circle, you can use this now. But in convention paper, they are going to clearly mention a method. Then they should go for that method only. But objective examination, they will not mention any method. Even if the examiner mention the more circle, somebody will use the analytical method. In objective examination, final answer is important. Which method you are using, not a criterion. Which method you are using, not a criterion. But the best method is the method which is going to take the less time and less calculation. Less time and less calculations. So there are so many examples are going to be there. Now this was already made the conclusion starting now. Before this now, whenever combined stress, normal stress in one direction 0 and tau xy is non-zero, more circle always intersect the y-axis and unsymmetric about the origin. Principal stress are unlike in nature. In plane Tom and absolute Tom max are same. So advantage is what? Now you can get all the stresses as well as the location also, you can get it now. So now we'll take a break. After a break, we'll take a 20 minutes break. Now we are going to start with this complete the almost the principal stress chapter. Hardly 10% portion is left out. That is how to find out the axial stress, bending stress and torsional shear stress. So after the break, I am going to discuss directly the elastic constants. So we'll come to the first chapter. There you are going to left out with exact definition of elastic constant, relationship between elastic constants and what the volumetric strength, that all you are going to discuss it now. So we'll take a break. After the break, you are going to continue. 6.5 I am going to start it. It is 5:42. So I am going to start it at 6:45. Sir, 6.5, not 6:45. 20 minutes break will be there. 6.5, the lecture will be start now. Already explained now, my dear friend. Here to here, what is this distance now? Sigma. This total distance, how much now? Sigma. And this height is sigma by 2. So this total distance sigma means the midpoint. Midpoint means this sigma by 2, sigma by 2. I have already explained and you are asking what the how we are getting this now. Is A. What is this A coordinate now? Mean this height is how much is now? So this is from this triangle. See there what a bisection point, midpoint, bisection point. So this total distance is what? A sigma. So this will be a sigma by 2. This height is also sigma by 2. So what is the radius now? By using your Pythagoras principle now, r is equal to what? The square root of sigma by 2 whole square plus sigma by 2 whole square. That is sigma by root 2. Mr. Rishabh Yadav and Satyendra Kumar. I hope it is clear now. If you have any queries, you can send it so that I am going to respond it. So otherwise, I will also take a break. You try with the analytical method, my dear friend. Why you want to unnecessarily waste the time now? Already given a shortcut method, Mr. Shubham. You try it. I've already given out now. We already done the so many questions. Why you want to complicate the question now? When I already getting the answer with a simple method, why you want to go for the analytical method now? When you are getting the answer straightforward method now, why you want to do complicate it now? Don't do the research now. You are sending what that question 4 times now. Sir, explain with the analytical method now. You try it. I have already done the what now? Analytical method already explained it. And I have given a simple method now. When you are getting the answer straightforward, simple way now, why you want to complicate the question now? In a GATE examination, what they will not see the what now? Who has spent more time to solve the question now? It is not a university examination now. Who is going to write down more number of additional? Who has taken what now? Who has given the more pages? They are not going to see it now. GATE examination, if you want to answer, which is going to take the less time. I have already given a more circular, done it for the simple method. And you are asking, sir, please solve this with the analytical method. I don't want to solve it now. You to solve it now. I have already explained the analytical method. I have solved with the graphical method. That is a simple method. When you are straightforward answer you are getting, why you want to complicate it now? Okay. So we'll take a break and continue at 6:05. Thank you.